Hello friend, I'm back again and I brought you another lesson of biometric recognition system. So no. Here I show you an example of multimodal biometric system. In multimodal biometric system we generally fuse the different characteristics of a human being. Here is a sample of an eye image. As I have already told you about the biometric iris recognition system, in which only the single trait is designed for verification system. So this is the part of eye is used for iris recognition system. This part is called iris, this is the pupil, and this part is called sclera. Okay. Hold on friends. So here this is a sample preview of fingerprint. And this is the sample images we take input for our biometric multimodal biometric fusion system. So what is multimodal biometric fusion system? In multimodal biometric fusion system we combine different biometric traits of human being for making a very high secure system. So these are the Matlab files which has been used for designing the multimodal biometric fusion system. So here we go. Initially we need to make the template of each biometric trait. So here this is the this file is used for face template. As you can see, okay, these are the coding for making the template of face, and here we used two-dimensional wavelet decomposition using the wavelet reverse orthogonal 6.8, having and 3 level of decomposition has been used, and we only extract vertical detailed coefficient, and this is the function used for extraction of detailed coefficient. This is for wavelet decomposition. After that, what we do for binarization, this is the process of this is the process of quantization. Process of quantization. Okay, where is my third face images has been put? I put those face images in third folder, and sequentially I call each images and making the template, and each template is being saved here according to the person's identification. I forgot to tell you, my friends, that this man these are the face images, we have taken 10 folder 1 2 3 4, and haven't been used these rest of the folder. These are the fingerprint samples, and these are the iris samples. Okay, as you can see, number 10, that means we only go till 10 number of folder. Okay, hold on my friends, I again resume. So yeah, Here we go. So I started making template, and all the template has been created in a very short period of time. Then I go to the fingerprint template. Here we read the fingerprint final image, which has been achieved by the pre-processing. That's an skeleton image. I show you how image look like. So fusion system, these are the fingerprint images, and these are the final images which were used for the feature extraction. So here I run the program. I'll encounter an error. Let me check what is the error type. 1-final.image jpg does not exist. Let me check why. Okay, because there are what has been done. 4 fingerprint 4. What is happened? Fourth folder. Let me check fourth folder. Okay, here there's an image missing, final.jpg. So I rename this image 1. Okay, now I got it. So I again encounter an error. Let me check what is the error. In fifth folder there is a missing of 1 final.jpg. I again go to the folder fifth. What is the problem here? Okay, this is the problem. So I again rename this image, and I again move to the run. I again encounter fifth, second, okay, fourth, F2, second. So I again move to the run. Okay, 1. Here we go. I run the template, and all the feature has been extracted within a very short period of time. 3.7. Then I move to the iris template. Open. Here I also again read final image of iris, which was the normalized images. I read these images. You can see these are the images. So I run iris template. I again encounter an error, 6 final.jpg. So I again run the program. I correct, and it takes only 0.4019 seconds. Again I got the code. So friend, I've successfully made the template of each trait, and each template is being saved by the name of iris template, fingerprint template, and face template.mat. So these are the database I had created. So what I'm going to do, I'm going to fuse each database. I open the program, and I taken the assumptions. I added these trait directly, and I take the assumption. The template which are having value more than 3 is equal to 1, which are having value equal to -3 will be taken as -1, and similarly for -2 and +2. And here I take the assumptions for calculate the distance. I sum up all the bits here and divided negative bit by the total number of bits. and the difference is being saved here as DMA scanner. This is for the genuine data, and this one is being used for creating the imposter data. So I again run the program individually, and both the program is being executed, and finally I move to the recognition phase, and for that thing I created a program which calculate the which show the receiver operating characteristic and display the performance of the program. And these are the receiver operating characteristic curve or a proposed fusion system. As you can see, it start depreciating from 0.94, little bit above than that, and till 0.8, and what I achieved 99.40% area cover is being covered. We are having a confidence interval 0.9693, standard deviation 0.089, and equal error rate is 0.09901. So having very less zero false rejection rate and having false acceptance rate 0.296. So having false acceptance rate 0.0296%, which is quite low as compared to the unimodal biometric system. So this is the whole algorithm of multimodal biometric system. Okay.